Spacecraft need deployable structures. Traditionally, those have been done with fairly complex articulating joints. Those devices are expensive and they're really geared well for large school bus-sized spacecraft. We have to get costs down, we have to get the physical size of the hardware down as well. What we focus on at Roccor is high-strain composites, a piece of composite that flexes. So you pull a pin and pop, the thing comes right out, and you can do that for a fraction of the cost. The rock boom technology, it's analogous to a tape measure where you have a coil, a rolled side of it, and then as you pull the boom out, the coil unravels, and then you have a strong, linear, stiff structure. It's where you're deploying out a sensor. When people think composites, they think lightweight, but there are a lot of other benefits. Composites are thermally stable, so they don't expand and contract like metal does. You can also embed conductors or your RF metallic components inside the composite itself. You don't need an independent wire harness to control those. And the application for this is really a matter of enabling high-speed, high-bandwidth communications between satellites, spacecraft, and the ground.
SBIR has been foundational to this business, but to get the funds and resources together to allow us to build first flight hardware and to get accepted for use on important space missions, it required commercialization readiness program funding and support. And in our case, that added up to about $3 million coming from the Air Force SBIR program office. It was leveraged against about $1 million from our commercial customer. And then on top of all that, Roccor was in a fortunate position to be able to invest about $750,000 of our own money through IRAD to complement all those investments and leverage them all up. Our technical point of contact on this project several years ago was Dr. Jeremy Banning, a world-renowned expert in high-strain composites engineering. As he moved on and up in his career, he handed off technical point of contact responsibilities to Captain Christopher Box down at Kirtland. And Chris Box has been fantastic picking up the engineering science of high-strain composites and then working with us to make sure that this product line is moving into flight applications.
The work they've done for us is advance the technology, specifically in high-strain composite materials. We've worked with them to advance that technology readiness level. By utilizing these materials in this way, we can lower the mass and lower the stowed volume for launch. The technology developed under this small business contract is actively going to help the warfighter on several small CubeSat missions to demonstrate RF comms, directly helping our national security.
With support from the Air Force SBIR office and funding support from our customer as well as investments from Roccor, we're taking this idea that we've proven out on a small CubeSat platform and we're scaling it up to a much larger SBIR class, or sort of a suitcase-sized class satellite application, which would bring even more capability to the warfighter. It's just the beginning of what we hope to be many generations of this kind of system that will deliver, hopefully, increasing capability to the warfighter.